Hello pre-calc students. Now we're doing not just polar coordinates but polar equations. And the trick with polar equations is that we need to have our polar and rectangular conversion formulas and manipulate our equations so that we can get things in terms of r or theta for polar, or in terms of x and y for rectangular. And so this is going to require a little bit more creative thinking. What we just have to apply each time is we got to use that, that x is equal to r cosine of theta, y is equal to r sine of theta, r squared is equal to x squared plus y squared, r is equal to the square root of x squared plus y squared, and theta is equal to the inverse tangent of y over x. So I know it's hard to see. Okay, so theta is equal to the inverse tangent of y over x, and you could also throw in there that the tangent of theta equals y over x. These are all tools that we have in our at our disposal to get things right. And another thing that's going to help you with these equations is it's going to take a bunch of practice doing a bunch of practice problems and recognizing how different rectangular relations look like in polar. So we have x equals -2, all right? And looking at our xy axis, right? When you have x equals -2, that's going to be a vertical line. That's a vertical line. So let's see how a vertical line can be represented in a polar equation. Remember, polar equation is a set of all polar coordinates that will make this equation true. And what we can do is, usually for polar equations, unless it's you're linear, you're trying to get things in terms of r. So we can see if we can use our polar conversion formulas to get things in terms of our polar terms. So x is equal to r cosine of theta, so we can definitely use that. So, excuse me. That's for YouTube. Thank you. I appreciate it. All right. So, r cosine of theta is equal to -2, and usually with polar equations, we're trying to isolate r. When we are isolating r, we can divide by the cosine of theta. So we can divide each side by the cosine of theta to isolate r. So r is equal to -2 over the cosine of theta. And one way I'd like to rewrite this is also equal to -2 times 1 over the cosine of theta. This is a perfectly true representation. And if you can think of it like this, we can know that 1 over the cosine of theta is the secant of theta. So this polar equation is r is equal to -2 times the secant of theta. So it's very important that we all have our trig identities memorized. Okay, so that's 15. Let's do 16. All right, and our first step for 16 is that this is a circle that is in standard form, and it's going to be easier if we get it in if we expand it out. So let's expand out our circle. Remember, this is a circle with a center at -5, 0, and a radius of 5. Let's expand things out so we can have a better time translating our rectangular circle into a polar circle. So x squared, all right, we're going to have x plus 5 squared is going to expand to x squared 2 times 5 is 10 times x is 10x plus 10x plus 5 squared is 25. All right, plus y squared is going to be equal to 25. And there's a couple things we can do to simplify here. All right, this positive 25, we could subtract 25 from each side and have these 25 cancel out. We can also subtract 10x from each side. And that's going to allow us to get x squared and y squared all on the same side of the equation. So when we subtract 10x, the 10x will cancel out on the left side, or will cancel out on the left side. We'll have negative 10x on the right side. So we can have x squared plus y squared equals 10x. Now that we have 10x, we know that the reason why I tried to get x squared and y squared by itself is that we have the equation r squared is equal to x squared plus y squared. So because r squared is equal to x squared plus y squared, we can replace x squared plus y squared with r squared. And r squared is going to be equal to, x can be written as r cosine of theta. So 10 r cosine of theta. Oh, and sorry, that's a negative 10, right? That's a negative 10x. That's going to be negative 10 r cosine of theta. And the one last thing we can do is we can divide each side by r. So we can divide the right side by r, the left side by r, and the r's are going to cancel out. That's going to cancel out one of the r's because that's r times r. And our final polar equation will be r is going to be equal to negative 10 times the cosine of theta. And if you have time, try graphing that in your calculator. That will show you a circle with a center of negative 5, 0, and a radius of 5. Okay? All right, to make sure that you're actually focusing here. All right. So 17, x is equal to 4y squared. And so this is a parabola. So let's see how a parabola looks like in polar. So this is a parabola. So let's see how you would, in general, if you can parabola. If you can in general find the patterns for converting a parabola from rectangular to polar, this will help you with other parabolas. So what we do here is that we have x is going to be equal to r cosine of theta, right? So if x is equal to 4y squared, all right? X is equal to r times the cosine of theta, and y squared could be written as, if y is equal to r sine of theta, y squared can be written as r squared sine squared of theta. So converting this into polar, we can look at this as r times the cosine of theta is equal to 4 times r squared sine squared of theta. All right? Now, at this point, we can divide each side by r to simplify. Again, make sure that you're focusing. All right. The r's are going to cancel out. So then you will have the cosine of theta is equal to 4r times the sine squared of theta. All right. You can then, at that point, divide each side by 4 times the sine squared of theta. And the reason why you can do that is because we are trying to isolate r. In polar equations, you are trying to isolate r. So we are trying to isolate r. So we're going to divide each side by 4 times the sine squared of theta on the right, and divide by 4 times the sine squared of theta on the left. Okay? And so that's going to make r equal to the cosine of theta over 4 times the sine squared of theta. We can simplify this as r is equal to, and follow this logic here, r is equal to 1/4, we could factor out a 1/4 here, the cosine of theta over the sine of theta, one of the sine of theta, because we have 2 sine of theta in the denominator, is going to be the cotangent of theta, 1/4 times the cotangent of theta, and then 1 over the sine of theta is going to be the cosecant of theta. 1/4 the cotangent of theta times the cosecant of theta. All right. Let me write this out here. Okay. So to expand, what I'm really doing is I could rewrite this as 1/4 times the cosine of theta over the sine of theta times 1 over the sine of theta. So that's how I get 1/4 times the cotangent of theta times the cosecant of theta. What I'm doing here is I have 1/4. I can factor it with 1/4. Cosine over sine is cotangent. 1 over sine is cosecant. So that's what I'm doing. All right. All right. Let's get through 18. Hope we can do that. So once again, we expand the circle. So we're going to have x squared minus 2x plus 1 minus y squared is equal to 1. All right. We could subtract 1 each side, have the 1's cancel out. All right. We can also add 2x to each side. All right. All right, so you have x squared can be r squared cosine squared of theta. Minus 2x can be minus 2. X is r cosine of theta. And then minus r squared sine squared of theta. Combine, because y squared can be looked at r squared sine squared of theta. And that's going to be equal to 0. Here, what we can do is we can factor out an r. All right, so we can actually factor out, what we can do here is we can say this is equal to r squared. If we add 2r cosine of theta to each side, then you're going to add 2r cosine of theta on the right side. these are going to cancel out. And when you have r squared cosine squared of theta and negative r squared sine squared of theta, you can factor out your r squared. And you can have r squared times cosine squared of theta minus sine squared of theta is equal to 2r cosine of theta. And at this point, all we can do is we can divide each side by r, and then when we divide each side by r, the r's cancel out, and then we just have to divide each side by cosine squared of theta minus sine squared of theta to isolate r. So the algebra is tricky, but all you're really trying to do here is isolate r. So that's going to give us a final answer of r is equal to 2 times the cosine of theta over cosine squared of theta minus sine squared of theta. All right. That is problems 15, 16, 17, 18. I'm getting the next part of these 19, 20 in the next video. And best of luck on your review packet.